was grade 11, so just going to go through some of the homework that you guys asked me to do, which was number 7 and 8 from the mathematical induction. So before I go into this question, what I want to do is I just want to discuss this thing over here, if you guys haven't seen it before. Now what that means is it just means sigma, okay, and it means sum of. So what we can have here is we have an index, and I'm just going to make something up here. Sorry, 2i plus 1, okay? So what this means is our index starts from 1 and we go up to 3 and we sum this. So what this is going to be, I start at 1 and I just substitute it in here, so we get 2 times 1 plus 1. That's the first one, so I start at 1. I go to 2 now, so add, so put 2 in there and we get 2 times 2 plus 1. Now I go to the next one, which is 3. And that's, we stop right there because it goes up to 3, okay? And then from here you can just work out what this is. That gives us 3 plus 5 plus 7. And we can get a total of 15. So that's all that sigma thing means. It just means the sum of. And you're going to be starting from this index, ending at that index, adding each term, okay? So if we go to the homework bit now, which is number 7, I'm going to go through. And we have sigma p is equal to 1. Now guys, this index can be whatever, p, I, n, j, k, whatever. It's a dummy variable, okay? Up to n, p squared equals so we need to prove that the sum from p is equal to 1 up to n of p squared is equal to this expression over here. So what I'm going to do first is I'm just going to expand this side first, okay? So remember what we do is we start from this index, 1. So if I put 1 in there, 1 squared is 1. Plus, I go to the next one, which is 2. 2 squared is 4. Plus, 3. 3 squared is 9. Plus, 4. 4 squared is 16. Plus, now I'm going to skip a whole bunch and I'm going to go right to the end of this thing and I'm just going to plug n in there and we get n squared, okay? Equals n plus 1, 2n plus 1, all over 6. So now this you have seen, all right? So we need to prove that this is equal to this. So remember the first thing, step 1, prove true for n is equal to 1. Okay, so on the left-hand side, if I put 1 in there, we get 1 squared, which gives us 1. On the right-hand side, plug 1 into here, and we get 1 plus 1, 2 times 1, plus 1, all over 6. All right, let's do this one quickly. So 1 times the anything will just give us the anything. So let's see what we've got here. That's 2, that's 3. 2 times 3 is 6. 6 divided by 6 is 1. So therefore 1 is equal to 1. Therefore true for n is equal to 1. All right, so here comes our assumption. Assume true for n is equal to k. So in other words, what are we going to get here? 1 plus 4 plus 9 plus 16 plus k squared, because I'm changing all my n's to a k, will be equal to k plus 1, 2k plus 1, all over 6. All right, our next one, we now need to prove true for n is equal to k plus 1. N is equal to k plus 1. Okay, right, so we've got this whole thing here. So that's 1 plus 4 plus 9 plus 16 plus k squared plus k plus 1 squared. Okay, equals this thing over here, k plus 1, 2k plus 1, all over 6, plus this k plus 1 squared, k plus 1 squared. Okay, so I'm just going to be working with this side over here. So grade 11s, you can see here I'm just going to get an LCD of 6 and multiply it up. So we get here k plus 1, 2k plus 1, plus 6, k plus 1 squared, because that's over a 1, so multiply by 6, all over 6. Okay, now what do we actually need? If I come back to this one over here, you remember I'm going to do my little cheat thing. So I'm going to change all the k's to a k plus 1. So this one here will become k plus 1. This one here will become k plus 1 plus 1. This one over here will become 2 k plus 1 plus 1 all over 6. So if we can show that this is equal to this, then we've got it. Okay, so what I'm going to do here is, first of all, I'm going to take out a common factor of k plus 1. And we are left with k, 2k plus 1, plus 6k plus 1, all over 6. All right, I'm just going to move to another page so you guys can see what's going on. I'm just going to rewrite that last step. So we've got here k plus 1 from the last step, k, 2k plus 1, plus 6k plus 1, all over 6. Okay, so my next thing I'm going to do is I'm just going to distribute this k into there, distribute the 6 into there, and get like terms together. So we get k plus 1, which is this outside one here, and on the inside, what do we get here? So that'll give us 2k squared. That'll give us plus k, that'll give us plus 6k, so we get plus 7k. Okay. Then, what do we get here? There's no numbers, so that's just plus 6 there, all over 6. I can factorize this to be k plus 1, k plus 2, 2k plus 3. So all I did was factorize this trinomial to be that, all over 6. Now, just to show you, just to remind you, what we're trying to get is we're trying to get this thing over here, which I wrote on this paper here. Okay, so let's just remind ourselves what we're looking for. So we're looking for a k plus 1, k plus 1 plus 1, and then a 2 k plus 1 plus 1, all over 6. That's what we're looking for. Now, if I have a look here, I've got the k plus 1, k plus 1. K plus 2 is exactly the same as k plus 1 plus 1, all right? Then there's 2k plus 3. Now, if I multiply that in there, I get a 2k. Multiply that with that, I get a 2 plus 1 is the 3. So I do have this. So what I'm going to do is I'm just going to change this one to be k plus 1. This will become k plus 1 plus 1. And then this one can become this, 2k plus 1 plus 1, all over 6. Okay, and what we've done there now is we have proved it. So, therefore, true for all n an element of the natural numbers. Okay, so that was question 7. Going on to question 8 now. All right, so question 8 is sigma p is equal to 1 up to n of 1 over p plus 1 will be equal to n over n plus 1. So what I'm going to do is just expand this one. So remember, substitute your index in for the first one. So we get 1 times 1 plus 1 is 2. So we get here 1 over 2. Plus, if I put 2 in there, 2 plus 1 is 3 times 2 is 6. So we get 1 over 6. Plus, if I put 3 in there, 3 plus 1 is 4 times 3 is 12. So we get 1 over 12 plus, and I'm going to go all the way to the end now and just substitute my last one in. So we get 1 over n plus 1 equals n over n plus 1. So now I'm going to be working with this one instead of this. Okay. Sorry, I don't need that equals. Right, let's go into our first one, which is prove true for n is equal to 1. Okay, so on the left-hand side, if I plug 1 into there, we get 1 over 1, 1 plus 1. That gives us 2. 2 times 1 is 2, so we get a half. Okay, on the right-hand side, 1 over 1 plus 1, which gives us a half. A half is equal to a half, therefore true for n is equal to 1. Okay. Step 2, our assumption. So assume true for n is equal to k. So I'm going to substitute all the n's to be a k. So we get here half plus 1 over 6 plus 1 over 12 plus 1 over k plus 1 equals k over k plus 1. All right, here comes the working out bit. So we have to prove true for n is equal to k plus 1. Okay, so on this side here we get 1 over 2 plus 1 over 6 plus 1 over 12 plus 1 over k plus 1. Now we need to change the k's to k plus 1. So we get 1 over k plus 1, k plus 1 plus 1. Okay, so k plus 1 plus 1 equals k over k plus 1 plus this thing over here, plus k plus 1, k plus 1 plus 1. Sorry guys, I just have to squeeze it in here. Plus 1, bracket over, and 1 over that. Okay. Right, so let's simplify this. So I'm just working with this side over here. So we get k over k plus 1 plus 1 over k plus 1, k plus 2. All I've done is just simplify that to be k plus 2. Okay, I'm going to get an LCD here, which is k plus 1, k plus 2. So that's got a k plus 1, it just needs a k plus 2. So we get here k plus 2 plus, that doesn't need anything from the LCD, so it's just 1. All right, I'm just going to work on the next page. And I'm just going to rewrite what I had there so you guys can see what we had. So we had k plus 2, k plus 1, all over k plus 1, k plus 2. Let me distribute that. So we get k squared plus 2k plus 1 all over k plus 1, k plus 2. Then I can factorize that and we get k plus 1, k plus 1. So k plus 1, k plus 1, all over k plus 1, k plus 2. This will cancel and you're left with k plus 1 over k plus 2. Now, what are we trying to get to? Remember, come back to this here. And what I'm going to do is I'm going to always work with your assumption with this one. And I'm just going to change the k's to k plus 1. So that top one will become k plus 1 over. The bottom will become k plus 1 plus 1. K plus 1 plus 1. So that's what we're trying to get to. And I'm just going to summarize it over here. So we get k plus 1 over k plus 1 plus 1. And that's what we've got here. So we've got the k plus 1 up at the top. And at the bottom we've got k plus 2. But k plus 2 is the same as k plus 1 plus 1. So this is equal to k plus 1 over k plus 1 plus 1. And we've proved it. Okay. So therefore true for all n an element of the natural numbers. All right, grade 11s, I hope that helped.